Welcome to Power Electronic course. In this course, I will explain more about silicon control rectifier. In this video, we will discuss about turn on and turn off characteristic of SCR. Let's start with turn on characteristic of SCR. Switching the SCR from forward blocking state to forward conduction state is known as turning on process of SCR. It is also called as triggering. There are three types of triggering. First type of triggering is forward voltage triggering. Second, thermal or temperature triggering, and gate triggering. Let's take a look at forward voltage triggering. In this mode, additional forward voltage is supplied between anode and cathode. When the anode terminal is positive with respect to cathode, junction J1 and J3 are forward bias and junction J2 is reverse bias. No current flows due to the depletion region in J2 being reverse bias except for leakage current. As voltage is further increased at the voltage VBO or forward breakover voltage, the junction J2 undergo avalanche breakdown so a current flows and the device tends to turn on even when gate is open. In practice, this method is not implemented because it needs a very large anode to cathode voltage. If the voltage is more than the forward breakover voltage, it generates very high currents which may cause damage to the SCR. Therefore, in most cases, this type of triggering is avoided. Second method, thermal or temperature triggering. The reverse leakage current depends on the temperature. The width of the depletion layer of the SCR decreases with increase in junction temperature. When the forward current voltage is close to breakdown voltage, the device is triggered by increasing the junction temperature. Therefore, the reverse bias junction collapses. Thus, the device starts to conduct. Method number 3, gate triggering, also known as gate control method, which applies a positive voltage to the gate terminal when the SCR is forward biased. This method can turn on a SCR as charge carriers are injected in the inner P layer, thereby reducing the depletion layer thickness. As the applied voltage increases, the carrier injection increases. Therefore, the voltage where forward breakover occurs decreases. From these three methods, the most widely used SCR triggering method is the gate triggering methods. The method is more efficient and easy to implement for power control. The following points have to be noted when designing the gate control circuit, which is DC gate triggering, AC gate triggering, and pulse gate triggering. Sedikit lagi. Sedikit lagi ya. AC line commutation. A reverse anode to cathode voltage will tend to interrupt the anode current. The voltage reverses every half cycle in an AC circuit so that an SCR in the line will be reverse biased every negative cycle and will turn off. This is called phase commutation or AC line commutation. Post commutation. To, to create a reverse bias voltage across the SCR, which is in the line of a DC circuit, capacitors can be used. The method of discharging a capacitor in the parallel with an SCR to turn off the SCR is called forced commutation. To summarize, to turn off an SCR, we can do first short circuit the SCR, reverse the anode to cathode voltage, cut off the current connection of the SCR, switch off the positive voltage supply at the anode, and change the polarity of the anode to negative. We have covered the turn on and turn off characteristic of SCR. Thank you. See you in next video.